Okay, so question 4a asks you to answer finding the integers c and d such that f of g of x exists in this form here, where we've been given f and we've been given the rules for g. So let's go about and put the composition together. So g is our inner function. So wherever there's a x in f, we're just going to replace it with all of this here. So our f function looks like this, where we're popping in all this green stuff into where there previously was an x. So f of g of x is this guy here. So we can clean that up. We can make that the square root of, let's expand this out, so x squared plus 10x plus 25 minus 9 equals a square root of x squared plus 10x plus 16. Now we just need to find c and d such that they multiply together, these numbers next to x multiply together to give 16 and add together to give 10. So let's start with the multiples of 16. So we have 1 and 16, 2 and 8, 4 and 4. Then we're just going to need to add them together to see what we come up with. So the top one's going to be 17, the second one's going to be 10, and the next one's going to be 8. So we can pick that this is the combo. The 2 and the 8 in here are the combo that are going to sit here and here. So we're going to put plus 2 here and plus 8 here. Now we need to answer the question properly. So it says find the integers c and d. So c equals 2, d equals 8, or just as validly, c equals 8, d equals 2. So we're going to need to remember that for the next question. So we had that f of g of x was equal to the square root of x plus 2, x plus 8. Now it says state the maximal domain for which f of g of x is defined. So let's just have a look at the general square root function. Square root of x looks like this, and its domain is for where x is an element of 0 to infinity, or x is reals positive union with 0. So we need x essentially greater than or equal to 0. So in this one, we kind of just cheat and we say that all of this is just x. So what we're aiming for is x plus 2, x plus 8, greater than or equal to 0. Now for these types of questions, I always recommend having a little graph of what's going on. So our x-intercepts would occur at -2 and +8. Sorry, this isn't perfectly to scale. And then it's a positive parabola, so we draw it in something like that. Well, not perfect, but you get the picture. So then we just need to find the range coming out of this that is greater than or equal to 0. So we're looking for this part here, include that dot, and this part here included all the way up to here. We are not interested in where it's below the x-axis. That's going to give us an undefined result, square root of a negative number, and that won't work. So from our graph, the maximal domain is given by x is an element of. So we're going to start at -infinity, but we can't include it. We're going to go all the way up to -2 included, and we're going to union that. So we're going to grab that and we're going to union it with +8, that's starting to look like a negative, +8 included, all the way up to infinity not included. And that's your maximal domain for this question.